Welcome you all. Cambridge A-level Mathematics. This is paper 4. This is mechanics. But this is for February March 2021. This is for 1 hour 15 minutes. But February March uh, exam is not available in this country. I mean, actually in Bangladesh, there are two sittings are available: May June and October November. So as usual, the instructions are given. You must write candidate name, center number, candidate number. Its marks is 50 marks. And one more important thing is that when you are writing G, you must use 10. G's value will be 10. Two particles P and Q of mass 0.2 kg and 3 kg respectively are free to move in horizontal straight lines on a smooth horizontal plane. So let me draw P and Q. Both are 0.2 kg and 0.3 kg respectively. They are free to move on a smooth horizontal plane. P is projected towards Q with speed 0 meter per second. At the same instant, Q is projected toward P with 1 meter per second, and Q comes rest in the resulting collision. Find the speed of P after the collision. Conservation of momentum. Let us apply that things in this rules, that is m1 u1 plus m2 u2 equals to m1 b1 plus m2 v2. Now let me place all this. 0.2 into u is 0.5, 0.3. Obviously you must be careful in thinking for sign, changing the sign because direction is opposite. m1 0.2, v1 is, let me write it v, and this is 0.3 and this speed is 0. So if we simplify, 0.2 equals to 0.2v, so v equals to -1 meter per second. So speed of p will be speed of p will be 1 in opposite direction. So speed of p is 1 in is opposite direction. Now see question number 2. A car of mass 1400 kg is traveling at a constant speed up a hill inclined at an angle alpha to the horizontal where sin alpha equals to 0.1. There is a constant resistive force of magnitude 600 Newton. The power of the car's engine is 22,500 watt. Show that speed of the car is 11.25 meter per second. So let me draw the diagram first of all. This is alpha and the horizontal where sin alpha equals to 0.1 and then constant resistive force of 600 newton since it's going upward direction, and the normal reaction as usual will be there must have some driving force. When we are solving this one, that time we need to find out what is the driving force given, and since it is with constant speed, must be careful, its acceleration will always be 0 meter per second. Resolving this force, this is 1400 g sin alpha, 1400 g cos alpha. Now let me find out driving force. So if I resolve in the inclined plane, d minus 600 minus 1400 g sin alpha equals to mass time acceleration. Acceleration is 0, so this will be 0. So d equals to 600 minus 00 into 10 sin alpha is 0.1. Now let us simplify this. 600 1400 into 10 into 0.1. So its driving force, sorry, I made mistake, it should be plus. So it must be plus. So driving force will be 2000 Newton. We know that power equals to work done per unit time. Work done is force into S by T. So F equals to, S F into V. So let me write power here. 22500 equals to force is 2000, driving force, and then V is there. So let me simplify, 3 zeros, 2 zeros, then 225 divided by 20, so it is 11.25. 11.25. The car is moving with speed 11.25 meter per second, comes to a section of a hill which is inclined at 2 degree to the horizontal. Okay, so let me, this is 2 degree, and then it's moving with the speed 11.25 meter per second. So P equals to F V. So F is here driving force, 22500 F into V is 11.25, 22500 divided by 11.25, that is force, driving force equals to 2000 Newton. Now let us find out, resolve all these things to find out acceleration. So it's going up, resolving upward direction, I mean parallel to inclined plane. 2000 minus 600 minus 1400 g sine 2 degree equals to mass time acceleration. I mean mass is 1400 into acceleration. Now simply let us simplify with the help of calculator. There is nothing. Acceleration will be 0.3 figure 651 meter per second square. Answer is in 3SF. So this is the answer for this one. And this is question number 3. A particle Q, I mean this is the particle Q, its mass is 0.2 kg. So let me write here 0.2 g is held in equilibrium by two light inextensible string PQ and QR. P is fixed point on a vertical wall and R is fixed on horizontal floor. The angle which is the string PQ makes this is 60 degree and 30 degree. So we need to find out the tensions in the two strings. So we can write Lami's theorem or any other ways we can solve it. Let me consider as T1 and let me consider as T2. So I will suggest you to resolve this force in this direction and it will be very helpful to solve. So this direction and that direction. Okay. This is 30 degree. So this will also be 30. So upper will be 30 degree. That is T2 cos 30 degree, T2 sine 30 degree. Now resolve this, I mean 0 to G, I mean perpendicular and then parallel. So it is important to find out this angle. For this reason this is 30 degree, so this is also 30 degree, this must be 30. So 0.2 G sin 30, 0.2 G cos 30 degree. Now if you resolve in this direction, there will be, since it is in equilibrium, so there is no acceleration. Okay, so T1, I mean T2 cos 30 degree minus 0.2 G sin 30 degree minus T1 equals to 0. Then we can find another one, I mean perpendicular to T2 sin 30. There is no more forces, and 0.2 G cos 30 equals to 0. Now it is necessary to simplify. 0.2 into 10 into cos 30 divided by sin 30. So it is 3 point, T1 is 3.46. I mean T2 is 3.46 Newton. Now if it is substituted here, we can get it 3.46 cos 30 minus 0.2 g sin 30 equals to T1. So 3.46 cos 30 minus 0.2 into 10 sin 30. This is 1.996. If 3SF, it will be 2 2. That answer will be 2. So T1 equals to 2 Newton. So this that. Let us see question number 4. An elevator moves vertically supported by a cable. The diagram shows a velocity time graph which models the motion of elevator. The graph consists of 7 straight line segments. The elevator accelerates upwards from rest to the speed 2 meters per second over a period of 1.5 seconds. Then travels at this speed for 4.5 seconds before decelerating to rest over a period of 1 second. The elevator then remains at rest for 6 seconds before accelerating to a speed of b meter per second downward over a period of 2 seconds. The elevator travels at this speed for a period of 5 seconds before decelerating to rest over a period of 1. Find the acceleration of the elevator during the first 1.5 seconds. That is, we are going to find out this part. So this is very easy case. Acceleration is 2 by 1.5. So 2 by 1.5, 2 divided by 1.5, 1.33 or 4 by 3 or 4 by 3 per second square. Now in second question, given that elevator starts and finish its journey on the ground floor and find V. That is, this is the things, it is going upward and this going downward. So two area will be same. So let us find out half this area of trapezium, half AB, A plus B into H. So 7 plus, this is 7 plus 6 minus 1.5, 6 minus 1.5, and parallel lines, distance between parallel lines, that is 2, equals to, and there it will be another thing, the sum of parallel lines will be 21.5 minus 13, 21.5 minus 13, then 20 minus 15, that is 5, plus 5, then distance between parallel line is V, then half, so half cancel. Then it is matter to simplify now. 7 plus 6 minus 1.5 into 2 into 2. So this is becoming 23 divided in. So 46 by 27, 1.70 3SF. So our velocity will be 1.70 meter per second, that is 3SF. And this is the answer. Now the combined weight of the elevator and passenger on its upward journey is 1500 kg. So let me write here. g. And obviously we are going to find out tension, so it's going upward direction with tension, and its acceleration obviously -2, we have already got in earlier steps. So resolve in upward direction is t minus 1500 g equals to 1500 into minus t. 1500 into 10 minus 1500 into 2. So its tension is 12,000 Newton. So this is the final answer. Okay, now let us see question 5. A block of mass 5 kg being pulled along a rough horizontal floor by a magnitude of x Newton acting 30 degrees above a horizontal. The block starts from rest and travel 2 meters in the first starts from rest and travels. Okay, let me use Subat. It is traveling 2 meters. Start from rest. We don't know v. Acceleration we need to find out. Time is for 5 seconds. So s equals to ut plus half at square. So let me substitute s is 2. Since u is 0, t, so it will be 0. Acceleration a, and this is 25. 5 square, that is 25. So acceleration is 4 by 25 meter. Okay, given that the coefficient of friction between the block and the floor is 0.4, find x. Okay, it is now necessary to resolve this. Okay, this is x cos 30 degree, this is x sin 30 degree, and there is friction is mu r 0.4 r. Normal reaction is this is r, this is 5g, dissolving in upward direction. R plus x sin 30 minus 5g equals to 0. So r equals to 50 minus half x. Now resolving in the direction of acceleration, direction of motion, x cos 30 minus 0.4 r equals to mass time acceleration. 5 times acceleration is 4 by 25. Now it is necessary to simplify. Root 3 by 2x minus 0.4 half x equals to 20 by 25. Now root 3 by 2x minus 20 plus 0.2x equals to 20 by 25. So root 3 by 2 plus 0.2x equals to plus 20 by 25. Now if we simplify this, 20 plus 20 by 25 divided by root 3 by 2 plus 0.2, close the bracket, equals 19.5. So x is 19.5. 5 obviously Newton. Answer is in 3SF. Okay, now the block is now placed on a part of the floor where the coefficient of friction between the block and the floor is different values. The value x is changed to 25 and the block is now in limiting equilibrium. Find the coefficient of the friction between the block and this part of the floor. Let me draw the diagram again. This is the box and this is 25 Newton, and then angle is 30 degree. 25 cos 30, 25 sin 30, normal reaction. This is 5G, this is R. We need to find out mu R. Find out R. And this is in equilibrium, okay? Limiting equilibrium. So obviously acceleration 0. Now upward direction dissolving R plus 25 sin 30 minus 5G must have acceleration is 0. So R equals to 50 minus 25 by 2. So 50 minus 25 by 2, 37.5. Okay, now resolving in this direction, 25 cos 30 minus mu R equals to 0. 25 cos 30 divided by 37.5. So mu equals to 0.577. So answer is in 3SF. A particle moves in a straight line. Question number 6. It starts from rest from fixed point O on the line. So t equals to 0, s equals to 0, or x equals to 0. Let me write x. The velocity, okay, v equals to t square minus 8t to the power 3 by 2 plus 10t. We integrate, v will be, displacement. This will be t square by 2 minus 8t to the 8, 3 by 2 plus 1, 5 by 2 divided by 5 by 2 plus 10 t square by 2 plus c. If t0, x0, then c is also 0. Then x will be t cube by 3 minus 16 by 5 t to the power 5 by 2 plus 5t square. Okay. Now let me use the values of 1. t equals to 1, so x equals to 1 third minus 16 by 5 plus 5. 1 by 3 minus 16 by 5 plus 5. 2.13 is the displacement. 2.13. First of all, that is minimum velocity. That is, there is two things. Velocity is minimum or maximum. Then the minimum velocity, this one. So to find out minimum velocity, we need to differentiate v. V equals to t square n t. So dv dt minus 8 into 3 by 2, 3 to the power 2, 3 by 2 minus 1. So that is half plus 10. That means 2t minus 3 4 are 12, t to the power half plus 10 equals to 0. dv dt will be 0. So if we simplify this algebraic simplification, square minus this is 6. I mean, we divided all these terms by 2, and t is written as t to the power half whole square. Now t to the power half equals to p. So p square minus 6p, just I considered p equals to t to the power half, 5. Then factorize p square minus 5p minus p plus 5 equals to 0. P minus 5, 1, p minus 5. So p equals to 1 and p equals to 5. So p is here t to the power half equals to 1, t equals to 1, and t to the power half equals to 5, t equals to 25. So now to see that whether it is maximum or minimum, let us do again differentiate d2vy dt square equals to 2 minus, I mean 12 half 6 t to the power minus 1 minus half, 2 minus 6 1 to the power minus half minus 4. So for this is max, and 25 minus 6 into, that is 2 minus 6 by 5, it is greater than 0. So minimum at t equals to 25. Now we need to find minimum velocity. That means t square 8 t to the power 3 by 2 plus 10 t. Let me use 25 here. 8 times 25, 3 by 2, 10 times 25. Now direct 25 square minus 8 into, sorry, to the power 3 by 2 3 by 2 plus into 25 minus two particles p and q. Okay, p and q. So this is okay. So 0.5 g, 0.5 g, and then 0.5 g cos 30, 0.5 g sine 30, then 0.5 G cos 45, 0.5 G sin 45. The normal reaction will be P, let me consider that P, Q. Then tension will be in this direction. Tension will be same since it is connected by inextensible string. And acceleration will also be same. Of 0.8 Newton is applied to P, acting down the plane, causing P to move. It is given M is 0.3 and both the plane are smooth in this section. Q rests in a smooth plane. Then P is also in a smooth plane. Okay. So for P 0.8 plus 0.5 G sin 30 minus T equals to mass time acceleration 0.5 times acceleration. Then this is downward direction. T minus 0.3 G sin 45 equals to 0.3 times acceleration. So 0.8, 0.5 G sin 30 minus 0.3 G sin 45, 0.8 times A. Okay, let me simplify. 0.8 plus 0.5 into 10 into sin 30 minus 0.3 to 10 into sin 45 divided by 0.8. Acceleration equals to 1.473 meter per second square. Now let me consider this is question 1, equation 1. T minus 0.3 G sin 45 equals to 0.3 times 1.47 into 3 plus 0.3 to sin 45, 2.56. Okay. Now it is given instead that the plane on Q rests in rough. Okay, that is there is a friction and its work is 0.5 joule. Okay, fine. Use an energy method to find the value of M. We know that work done equals to Ke plus Pe. So let me use that. Work done by tension is 0.8. I mean this TT gone, and then friction 0.5. Both are passing with kinetic energy half mv square 6 square, and that is then half m into 6 square. It's increasing plus going down, it is decreasing. minus 0.5 g sine 30 degree into 1 plus mg sine into 1. Tension for tension, it's all right, cancelled. Okay, now let us simplify. 0.3, then 0.18 m minus 0.5 into 10 into sine 30, 2.5 plus 10 into sine 45, 7.071 m. 0.3 plus 25 minus 0.09 equals to 0.18, 7.071 m. 0.18 plus 7.071, then our answer is becoming 74. So thank you very much.